So you should be able to see my screen now.
Yes.
And I'm going to talk about the basic concepts of Git. And I will just get started. So what is Git? As I said yesterday, Git is a distributed version control system, and it does not rely on a server-client model. Instead, everyone has a full copy of the entire project. Repository is what it's called. And in that is the complete history, the metadata, etc. And everyone can work independently. And if you are working together with someone, then an optional server is used to distribute changes. I mean, you can keep it just on your own machine and just committing your changes and never pushing them. But if you're using Git at its fullest, you're working together with someone, or also if you are using it on several machines, then you will be using a server to distribute the changes, if nothing else, to yourself on another machine or to your colleagues. So why would you use Git? Well, it's popular. So many projects already use it. And people know how to use it. They can tell you how to use it. If you Google something about Git, you will get a lot of answers on Google, and that is also useful. Git relies on hash sums, and it has a built-in data corruption detection and built-in security. It is distributed, as I said, and it's fast, simple, and flexible. And it's also free and open source. So there's many reasons to use Git as opposed to some other version control systems. How does Git store the history? Well, what is inside of a repository? And I should probably say one thing more about this lecture today. It is not that you don't need to remember everything that goes on here today, but this is a way that hopefully will help you to better understand what goes on behind the scene in Git, because that can sometimes make it easier to figure out how to fix, for instance, a merge conflict or other things when you know what is happening. So here, let's try create a repository, and I'm going to type along here, and if you want to, you can do so as well. So I'm creating a repository, and I already have one because I was testing it earlier. So I am going to call my repository repository2. And I'm going to change to this repository. Like this. And there's nothing in it right now. I'm going to do git init to initialize my repository. Again, I get the blurb here about how you can change the branch. Just ignore that. It is irrelevant. The only thing that matters down here is this, for the purposes of what we're talking about today. And now we have initialized our empty Git repository. If you do find, you will see what is in it. And I believe if you're using git bash on Windows, these commands should also work there. But you see there is a directory .git, which is where Git stores a lot of metadata, but also the changes and everything here. And you can see it follows this tree structure here. So here's the repository. Here is the .git. And under that are branches, hooks, info objects, etc., etc. So if you had more branches, they would be here and so on. But you don't need to understand this right now. We are going to talk more about this in a very short while. This is just to show what happens inside of a repository, and as soon as it has been initialized, these things are created here. And if you check to begin with, most of these directories, they are empty and the files are not interesting. There isn't anything in it yet. So we can try to do the same thing here. You see, there is nothing. And you can, the head here, that is what it is pointing to right now. It is pointing to the tip, and it is going to, it's called master because that's the default. And that is where the head pointer is pointing to this branch. So there's only one branch. Let's see if there's anything in the description. There's not. You can edit a file that is called description if you want to give some information about your repository. So far, nothing has happened other than Git has initialized a repository and is now ready for putting stuff there. So let's try and add some content. And this line here, echo, and some line, and then this direction here, that just means that it is repeating this, it's echoing the word, this is very interesting, and then it's throwing it to the file.txt. So I'm going to do that. And I'm sending it to the file. This is not a Git command, it is a Linux command, and it should also work in Git bash. So now I have a file called file.txt. I would like to first ask, is this text large enough? Can you read it?
Like we have to little bit squint our eyes. It would be helpful if you can just increase it a little bit.
I will increase it.
Thank you.
Just need to move stuff around here because of this window. Okay, now it's a little bit larger. So now I added some content. I created a file. I'm going to add it or stage it to my repository. And then I'm going to commit it. And now I'm going to use this shortcut that you will see used again. So I will say git commit -m, and then I can write a message directly here instead of opening the editor. It is simply a shortcut. This is not a good commit message, but I'm just writing something here. And as you can see, now the first commit message has been added to this here. And we can try and do find. And you will see here now there is stuff going on here. This I have marked here in red in the tree here. There's the file. It's here. And then under Git, there were things happening in the log, which is somewhere here. The head is pointing here. There is things happening in the commit edit message because I added a commit message. And that is under this. And under the objects are the text I actually put here, and there are some hashes here. They will be different than the numbers put here, of course, because each time I do this, I get a different hash. But the hash is always, you can see it's probably almost similar here. But the the hash is always unique for a commit message, and you can use it to go to this specific message. And that is something that will be talked about when we go to traversing the commit tree, which Diana will talk about. So everything inside of this repository is part of the working tree, which is what we call it in Git. It can also be called the workspace. And under .git at the moment, the working tree contains only one file and the metadata for it, which is the file.txt. Git add and git commit commands tell Git to care about the file, so it's now following it. And the things under, is the .git itself is not included, that is this one here, but all things under it is considered the working tree. So objects, the file we just created and put there, it's considered an object for Git, and they are stored under .git objects, so under this directory here. And you can see it created things here. And Git uses what is called content-based addressing. There is a hash sum, this one here, is computed from the content of the object. And the hash will uniquely identify the object, as I said. Two objects with identical content will have the same hash and will only be stored once. And that is also good because that takes up less space there. So we can actually compute a hash manually with this command here. And then you will get the same hash as you got otherwise. So you can see. So you can try and do that if you want to. Then it will create a hash. And we can then go and find the corresponding object. So the first part here will be the directory, and then the rest of the hash is shown under it. And that is what we have here. And you can confirm that two files have identical content, then they have the same hash. So let's try and copy the file I just created. And then create a copy of it. And then I will try and create a hash for it. And then I will do the same for file 2. And you can see here, the hashes are the same. So all is good. And you can see the hash is a very long string. And if you want to go to that place in the commit tree, if you want to address this hash, you don't have to use the entire one. You only have to use enough that you are sure it's unique. And it's usually enough to take the first 8 numbers or 8 characters. So. But if you have a large project, if there is a lot of files in it, then maybe you need to use more. But usually 7 or 8 is enough to uniquely identify an object. And if we need more characters, then an error message is printed. And you can try this yourself if you want to. You can, but in this case, you need to simply add more stuff to it before you will get in that situation because there is only one object right now.